Programs are wonderful when they work, but almost no program ever written by anyone worked perfectly well the first time. Almost every program ever written had bugs. One by one, we remove the bugs and fix things up, and by the end we hope we've caught them all, or at least all of the big ones. When you're debugging and processing, you have two main tools, the comment and the print statement. Let's see how to use them. Here's a little program that draws 4 circles. I've created some variables to hold their center x and y values. I'd like them to be arranged in a horizontal row. So let's run it. One of the circles is in the wrong place. Well, we could probably fix this just by looking at the program because it's so simple, but suppose it was a huge program with hundreds of lines. How could we go about finding just exactly which line has the problem? Let's start by using the comment. There are 2 types of comments. The first kind of comment is called the multi-line comment. This tells processing to ignore whole bunches of lines. The comment starts with 2 characters, a slash and a star, one right after the other. Then processing ignores everything until you close the comment with the same 2 characters in the opposite order, a star and then a slash. All the text between the opening and closing comment markers appears in gray. This is processing's way of telling you, I know there's something there, but when it comes to running the program, I'm ignoring it. Let's use the multi-line comment to turn off all the circles. This will let us confirm that something in the circle drawing code is the problem. Great. Now nothing is being drawn because we've turned off all the graphics, but that's still useful because it confirms that all the other stuff is running properly. I often use the multi-line comment for just this sort of thing, where we want to block out a big section of code. When you're looking to see what's wrong with a big program, you can temporarily turn off whole big chunks of it this way. If your problem goes away, you know it's something in the stuff you commented out. If the problem persists, you know it's in the stuff you left in. Let's now take away the multi-line comments. Notice that the text loses the gray color. Now I'll use the second kind of comment, which applies to just a single line at a time. If you place a pair of slashes on a line, one right after the other with no space, the slash slash tells processing, ignore everything until the end of the line. So this is a great way to temporarily turn off a single line of your program without deleting it. So I will comment out all but one of the 4 calls to the ellipse routine. This way, even without looking at the numbers, when I draw the picture, I know that the ellipse that gets drawn will be due to the one line that I haven't commented. So let's run it. Well, that looks fine. So now let's uncomment the next ellipse and run it again. Well, that looks fine as well. So let's uncomment the next ellipse and run it again. Aha, there's the problem. If we want to be absolutely sure, we can comment out the first 2 calls to ellipse and just leave this one alone. Running it, we see that, yep, this is the ellipse that's going wrong. So we know just by looking at this that there's something going screwy with the center y value of this ellipse. But what's wrong with that value? In such a short little program like this, we can just look at it and see the problem. But suppose that this was a huge program, and the y value is coming from some complicated operation somewhere else in the program. What we want to see is the y value that's being used at this line. So now we use the print statement. Now there's a whole video on print and print line. If you haven't seen that yet, it will explain what I'm doing here. Really, I'm just printing out a little message, and then the values of the center y variables for the first 3 ellipses. Let's run this. Down in the output area, we get white text as a result of our print statements. And now it's obvious why our third ellipse is in the wrong place. it doesn't have the same center Y value as all the others. In this case, it was just a simple typo, but often this technique will help you catch problems like this, but that are the result of some more complicated operation. Armed with this information, we can go back to the definition of that variable and fix it. Now we run the program and success. So with a combination of comments and print statements, we isolated the problem, checked the value of a variable, and fixed it. You're going to find that you do this a lot. Errors in computer programs are a fact of life. Everyone's programs have bugs. So don't get down on yourself for having bugs in your program. Think of them instead as part of the process, like sketching something. Often, when you start a sketch with a pencil, you start with something rough. Then you stand back and you notice maybe that the proportions are off, or maybe the tones are wrong. Well, that's no problem. You erase one thing and you redraw it, you lighten another thing, and bit by bit, you remove the stuff you don't care for and reinforce and clean up the stuff you like. That's the very same thing as debugging. Absolutely everyone goes through it. You will get faster and more efficient over time, but never forget the power of a fresh pair of eyes. If you get really stumped on a bug, take a break. And when you come back, you'll often spot the problem right away. Or, if you can recruit a friend's help, even the process of explaining what it is you meant to do can help you spot your problem. And if not, well, now you have two of you working together to find the problem. Most errors are a bother, but nothing more. With comments and print statements, you can track down what's going wrong and fix things up.